Alright, welcome. This is Chuck solution matrix. So this is a problem involving inverse here. So we can solve matrix equation using the inverse of matrix. So what is a matrix equation, right? So let's say we are given that A, B is equals to C, where A, B, and C are matrices. So this will create what is a matrix equation, because it's an equation which consists of what? Of matrix here. So it's A, B equals to C here, right? So we can find A, we can also find B here by using the inverses here, right? Either the inverse of A or the inverse of B. Right, so let's say maybe the question is saying find B. So to find B here, we are just going to consider that there's B here and there's A. So what is multiplying B is A. So we are going to multiply both sides with the inverse of A. So to multiply with the inverse of A here, we consider the position here of A. So A is in the first position. So we are going to multiply on the first position such that A inverse times A here will give us the identity matrix. Because A inverse times A will give us the identity matrix. Then times B equals to A inverse times C. So we are multiplying in the first position on the left hand side such that we have A inverse times A, which is the identity matrix. So we also do the same thing on the right hand side. We multiply in the first position. So this will give us identity matrix times B, which is equals to A inverse times C here. So B is equals to A inverse times C, since identity matrix times B will be equals to B here. Alright, so let's say maybe they say find A here. So to find A, we are going to see that A is in the first place and B is in the second place here. So it means we are going to multiply both sides by B, since we need to find A. So to find A, we are going to multiply here in the second place of B here. So what we are going to have, we are going to have A times B, then B inverse here, which is equals to C times B inverse. So B times B inverse here will give us the identity matrix. But take note of the position that we are multiplying here. We are multiplying in the second position. So on the other side, we also multiply in the second position here. Alright, so we can find our A here. So A times the identity matrix equals to C times B inverse here. Alright, so A times identity matrix still A. So A is equals to C times B inverse. So we can find our A here. Alright, so let's go to the example so that we see what we are talking about here. Alright, the matrix A is equals to 3, 2, minus 1, minus 4, 8, 4, minus 1, 2, 3. Given that AB is equals to this matrix. So they are saying if you multiply A and B, the answer is equals to this matrix. But you can see A is given, but B is not given here. Alright, so find the matrix B here. Alright, so let's just see here. The question is saying we need to find the matrix B. So to find the matrix B here, it means we need to multiply both sides of the equation with the inverse of A, since we need to find the matrix B. So you can see A is in the first position here. So we are going to multiply on the first position here, such that we are going to have A inverse times A will give us the identity matrix. So we'll also do the same thing on the on the right hand side here. We multiply with the A inverse. Alright, so then from there we can now find the inverse of A here. So the inverse of A, we've been discussing this on how to find the inverse. So I would encourage you to go and look for the videos on finding the inverse, so that you get more familiar with finding the inverse of a 3x3 matrix here. Alright, so here we are going to have the identity matrix times B, which is equals to A inverse times this matrix. So our A inverse here, we are going to have B is equals to the inverse of A times this matrix, which is here, then which is going to give us this one. So it's very simple here. So it's row by column, then you get this matrix. So that will be our final answer when you multiply the inverse of A and this matrix. Right, so this is the example that we have. Alright, then this is another example. Given that Q is equals to this matrix, my 1 minus 1 0 5 minus 4 1 2 2 1 here. All right, then they are saying find the inverse of Q. Then item 2, given that PQ multiplying P and Q will give you this matrix, and they say find what? Find P here. Alright, so we are going to find the inverse of Q. So inverse of Q, first we find the determinant. I know you are familiar with the determinant by expansion of the first row here. So determinant is equals to minus 3. So that's the determinant, expansion of the first row. Alright, then matrix of cofactors. So matrix of cofactors, we find the matrix of minus for each and element here, which is in the matrix here. We find the matrix of minor. Then we multiply each and every element with plus, minus, plus, minus, plus, minus, plus, minus, plus here, so that we can have the matrix of cofactors. Right, so please kindly go and look for the video of inverse of a 3x3 matrix. We are just building on those concepts, so make sure you know inverse of a 3x3 matrix. Right, then from them we can have this is our matrix of what? Of cofactors. Right, so from the matrix of cofactors we can now transpose this matrix of cofactors so that we get our adjoint. So our adjoint of Q is equals to we are interchanging the rows and the column here to get the adjoint here. Alright, so now we can write our inverse. So inverse of Q is now equals to 1 over minus 3, then minus 6 1, minus 1 minus 3 1 minus 1 18 minus 4 1 here. So that's our inverse here. Alright, so now we go to this part here where we are saying PQ is equals to this matrix, right? So PQ multiplying P times Q will give us this matrix. So they are now saying find P. So to find P, it means we are going to multiply with the inverse of Q on both sides here. Because we need to find matrix P. So we just look at the position of Q. So Q is in the second position. So the inverse is going to multiply in the second position here. Right. So if you look, we are going to multiply in the second position on both sides here. So it's PQ times its inverse, so that we can have the identity matrix is equals to this matrix times Q inverse here. Then from there, Q times Q inverse will give us the identity matrix here times P. Then this matrix times the inverse of Q. This is our inverse that we have already find here. Then we can now just, this is a constant, it's a scalar, so we can put it aside here, but then we maintain the order of our matrix here. It's this matrix times this matrix. So we can have P is equals to 1 over minus 3, since P times the identity matrix is equals to P. Then we have this matrix times the other matrix here. Remember, this is just a constant, so a constant is in the first position here. We just factor, we just put the constant here, and we maintain our matrix, the order. So don't change the order here, like maybe putting the inverse in the first place. No, we are just taking the constant aside here, then we take the order of the matrix. We are maintaining the order of the matrix. Take note that matrix multiplication is not commutative. So the moment when you exchange the positions here, like taking the inverse and put it in the first place, you have already violated the commutative law, where we say the matrix multiplication is not commutative, right? So in this case, we're just taking this constant, then this is the matrix that you just maintain here in the second place here, and we move, then we multiply row by column. So this will give us P is equals to minus 1 over minus 3, then this matrix here. Alright, so thank you for watching the video. See you in the next lesson.